this video I'm going to talk a bit about how I'm building the battle system of my JRPG. If you ever wanted to know how a battle like this actually works, this video is for you. This is not a step-by-step guide because this kind of game has too many particularities. Every game is its own system. What I want to do is give you the general idea, something that might be useful if you're trying to build something similar and you don't know exactly where to start. So let's go. This is the first devlog of Omicron Historia. Omicron Historia is inspired by the classic JRPGs of the SNES and PlayStation era, in particular Final Fantasy V and Wild Arms 2. Two systems where, to me, turn-based battle shines in a way nothing else does. Final Fantasy V is the most complete one for me in that department, the job system, the abilities, and an ATB system that evolved the old fixed turn order, the one where you never had a clear picture of who was about to act. Wild Arms stands out for giving characters a second resource besides MP. That's something I always found cool and useful because it adds variety to a fight. And the active side of my battle is a little inspired by Grandia, even though my system is a bit simpler since casting works differently in my game. But let's get into it. Coming from RPG Maker, building a system like this is a serious challenge, and it took me a long time to figure out where to even start, especially considering that RPG Maker hands you an entire battle system and Godot hands you, well, not much, so good luck with that. The good news is that in Godot your game and your battle is not going to look exactly like 100 other games out there. That's the good part, and it's also the most complicated one. And there's a second upside. If you came from RPG Maker or from any similar system, you have something that matters. You know what a battle feels like, you know how important feedback is, and you know how a fight is supposed to behave. That knowledge doesn't get lost, it just takes a different path. One important decision I made was how to separate data from nodes. A battler in my system is two things. There's the data, which includes things like name, HP, MP, and skills. That's a resource and it basically holds nothing beyond what's inside it. It doesn't know anything about what's on screen, about the scene tree, or about whether the battle is happening at all. And there's the node side, which is a sprite on the battlefield with an animation player, hit reactions, shaders, and other information. That one is a Node 3D and it holds all of that. Why does this matter? Because the resource is just a file, a .res sitting on the project folder. I can make a new enemy without changing a single line of code. And because those files live outside of a scene, they survive outside of the battle, which is exactly what I want for the heroes, but not exactly what I want for the enemies. Let me explain. Resources in Godot are shared by reference, so touching one .res always touches the same object in memory. If a hero loses 40 HP, that same reference is what a menu shows later. That's the behavior I want. For an enemy though, it doesn't work so well. If I kill one bat, every bat in the game dies forever. So this little snippet here is useful at the start of every battle. That creates a deep copy of the resource so the original stays intact. Another decision I made, and maybe it's not the best one, is that my enemy batter class inherits from my hero batter class. That's useful because the behavior of both is exactly the same, so I don't have to write the same things twice. That's something I might have to revisit later, but so far it's working. So every attack, every spell, every enemy ability in Omicron is a resource, not a script. It's just a file, so it's basically the same logic as my characters and my enemies. The actions are all defined in the editor. Each one of them has a property called sequences, which works like a timeline that any battler can read and use to perform a skill. So every wind up, swing, impact, every timing, every shake, every flash is created in this vector. So a 3-hit combo is in 3 special cases in code. It's a list with 3 items in it. That's the whole feature, which means I don't have to edit anything directly in code. One property I want to highlight because I really like it is damage delay. It lets me define exactly when an action creates the damage pop-up, the impact, the shake, everything else that gives feedback to the player. The number appears when the sword actually connects the attack, and that's basically the difference between a game and a spreadsheet. And this is basically what the code does when it receives that data. The battler reads the information as a list of things he has to do, which includes animations, weights, VFXs, and audio. At the end, it emits a signal saying the action is over, which notifies the battle system. Let's talk about that system now. The important thing in a battle system is organizing it into distinct phases, especially because you don't want your whole battle system running inside a process function. Don't do that, otherwise you're going to spend months trying to understand what you wrote. The way I found to organize this better was with state machines. I used this one from GD Quest. There are more complete ones out there like the state machines in the Limbo AI plugin, explain, but I've never needed anything more complex than this. What I think really matters is that your battle needs a complete loop. It can be simple or it can be complex. What matters is that you split the fight so each moment is isolated from the others, because that's going to save you a lot of headaches as the system grows. Consider that the system will need turn checks for who is still alive and who is still acting, whether a monster has already been taken down, whether there are active statuses, and so on. The more compartmentalized the better, and the easier it is to debug and fix problems. Since my system is still in development, right now you can't lose or you can't run. The battle just locks up and keeps going forever. But I'll get there soon, so I'm only going to talk about the states that actually work at the moment. The opening state is actually split in two. Waiting start just holds until the scene has been loaded, and transition and start is the one that does the work. The characters and the enemies walk toward their positions on the battlefield, we have transition effects and the music starts playing. I don't have this yet, but this would also be the moment to trigger global passive skills or advantage that proc at the start of the battle, but that can wait for another video. The next state is ATB, Active Time Battle, the part where everyone races along the bar. There's a single bar for the whole fight and every batter has an icon traveling across it. When an icon reaches the end, it's time for the batter to act. There's one decision in there worth mentioning. The obvious answer is that agility makes your icon move faster. I didn't do that. In my system, when your turn ends, your icon doesn't go back to the very start of the bar, it goes back part way along it based on your agility. So that's basically a head start, not a speed. The reason, of course, is readability. If agility is a speed, stack enough of it and the icons start passing each other on the way and the player has no idea who's acting next. With a head start, everybody moves at the same pace and some simply begin further along. You look at the bar and you know the order. Stats, formulas, and that kind of detail can wait for another video because there's a lot to say there and none of it is balanced yet. Now let's see what happens when a battler reaches the end of the bar. If it's a character, we go to the hero turn command state where the player selects commands. One caveat in my case is that this state is already a bit too long, considering that the whole selection and targeting part happens inside it. Even though targeting itself is an external class that I call only to handle the targets, which is generally the annoying part, because consider there are skills with many types of targets. Single, all, single enemy, all enemies, self and so on, not counting things like handle targets for example. That's why I thought it was a good idea to separate that part. But anyway, it might be time to refactor and split the command part better. What matters though is that you keep spotting this kind of problem while you develop. Obviously, having a structured plan beforehand helps, something like a GDD or a software engineering document, but things can always change, so it's important to be ready for that. So hero turn command and enemy turn only differ in how each state arrives at the action. This is where that signal that I mentioned earlier gets heard. When the character or the monster is done acting, the action tells the battle it finished and the battle system moves on to the next phase. After the action, we finally reach the final state, which is called death checks. This is where the system checks whether the battler is alive or dead, checks for the correct animation, whether a collapse effect is requested in the case of enemies, and then whether every enemy has been defeated. In that case, the battle goes to victory, which basically plays the victory theme and ends the fight. That part is already working. If the battle was called from a map, the system already handles transitions. If there are still enemies alive, the system goes back to the ATB phase and the cycle continues. An almost perfect battle loop. There's one more system I want to show and it's the least finished of all of them. Every turn-based game needs something that it isn't just attack or spell. Final Fantasy has limit breaks. If you ever played Wild Arms, you already know exactly what that is. I called mine boosts for now, which is just a placeholder. The party shares one meter that is drawn as 3 bars. Landing attacks fills it, and on your turn you will spend 1 full bar to put a boost on your hand, up to 3, and your next action spends whatever you're holding. Each action carries a list of boost effects, and the damage roll falls through every one of them. The standard one is a quarter more damage per boost, which means a skill that wants to spend its boosts on something other than damage, extra hits, a longer status, a wider target, doesn't need a special case in the code either. It just carries a different effect in that list. Taking a boost doesn't cost your turn, the command list keeps the cursor, and only the button grays out when you can't go any further. Nothing is actually spent until you commit to an action, so reading a menu never costs you anything. Never punish a player for thinking. And the rest of it is just the feedback, and this is the part I had the most fun with. The sprite pulses blue and the outline beats faster the more you're holding. There is a trail of fading copies that follows the battler, and each boost creates an elemental orb that spins spins around the character. When the action starts, the orb shoots at the target and is consumed whether it hits or misses. At the end, it's just a super cool effect. So that's the base of it. Characters are files, actions are files, and the battler just plays them and the state machines decide what's happening at the moment. One thing to take from this video, decide early what's data and what's behavior. That decision lets me add an enemy or skill in seconds instead of digging through code, and it's something I do again from day one. The battle system is still being built, so if you want to see how it turns out, this is where I'll be sharing it. So tell me what you'd like to see in the next video. And if you want to talk to me, check my Discord. The link is down in the description. That's where I post the work in progress and where you can ask me anything about the game. And if this was useful, don't forget to subscribe. Thanks for watching and I'll see you guys in the next one.